when it comes to uh, when the size of the material is reduced to nano scale, so typically that is less than 100 nano, its physical, chemical, optical, and electrical properties changes dramatically. So that's what till now we have seen those properties in the previous slides. So this is mainly happening because of the two phenomena. That is, one is surface effect. That is surface effect in the sense that the particle size is less. The surface to volume ratio increases. Because material is getting very tiny and tiny within the available volume, more nanoparticles will fit. So as more nanoparticles will fit, the reactions and their mobility, everything will be effect on the surface. So particle size decreases, surface to volume ratio increases. That means within the available volume, more number of particles will be incorporated, and a larger fraction of atoms lie on the surface compared to the interior. And these surface atoms are less stable. So within, so generally when you consider bulk material, within the bulk material we can observe that atoms. But when the atoms are tiny and the material are tiny, so the particles available on the surface itself, not on the inside of the particle, inside of the bulk. So as the particle it becomes its layer like a material, so all the atoms will be appear on the surface itself. So the surface atoms are less stable. So even with the small energy also they may come out of the their local position and will go to reactive with other atoms. So more reactive and have unsatisfied bonds. So their bonds also about to their bonds also like very brittle to break easily. Then that is surface effect under nano size, and then as a resultant higher chemical reactivity, and the prone to lower melting point, and then enhanced catalytic activity, and the changes in mechanical strength and surface energy, and all these are the important parameters as a resulting under nanomaterials, nanoparticle level. So from the above slide, y-axis properties such as dispersion or reactivity increases sharply as particle size decreases. That we have noticed. So smaller particles show much higher surface effects. Then when it comes to properties, once again, deviation of properties with the size of the particles. So particle and then bulk level, nano level. If you see, copper at bulk level behaves like opaque, whereas copper at nano level behaves like transparent. So copper, if you make completely like a thin sheet, so we can observe one side of the particle, one side of the picture to the other side, that is transparent, it becomes like a transparent. Generally, copper has a sheet that will be used in medical applications or in preparation of semiconductor devices like that. A thin sheet will be used, this copper, for the conductivity where required. Similarly, platinum. So at bulk level, it behaves like an inert one, whereas at nano level, it behaves like a catalytic. How different, how to completely opposite behavior. And similarly, aluminum at bulk level it is stable, but at nano level it is a combustible. Similarly, gold, that material is also at bulk level solid, looks like a solid, but at nano level it looks like a liquid. So that everybody aware of gold, with pure this one behaves like a smooth kind of material. So similarly, that means hardness is very less. Similarly, silicon at bulk level it behaves like an insulator. At nano level it behaves like a conductor. So these are various properties, how they behave like at bulk nature, how they behave like nano nature. So now some more are features of nano structures. They will be generally based on these properties and based on these features. We can categorize nanomaterials. See, for example, the center one nanoparticulate materials. So, if you take nanoparticles of type of ultra fine aerosols or nanocapsules type or quantum dot nanoparticles, nanotubes. So everyone is matter of nanometer distance. So 20 nanometer, 10 nanometer, like that. So less than 10 nanometer, like that. So based on those differences itself, you can find out various applications. For example, nanocapsules. So they you can find out applications like origin, natural and unintentionally released, manufactured. So these nanocapsules are also observed that under it is not that much difficult to get them to the level of nanocapsules, easily can be identified. Similarly, when it comes to quantum dots, so chemical compositions are mainly required for identification of these quantum dots. So these quantum dots of kind of particles can be observed in metals or metal oxides, polymers, carbon, semiconductors, and biomolecules and compounds. Similarly, when it comes to nanotubes, so you can observe that aggregation state, single particles, segregates, and agglomerates, and similarly, ultra fine aerosols. These nanomaterials results in dispersion in gases, like observed in gases or liquids and solids, like gels, and ferrofluids and matrix materials. So in such applications, we can observe that ultrafine aerosols. Similarly, different shapes, spheres, needles, and platelets and tubes, all these can be observed with nanoparticles. And surface modifications, untreated as obtained in production process, coated, and surface modifications can be done, in which, as an example, nanotubes. So these are parameters. These are parameters are taken into consideration for characterization of nanomaterials. Based on these properties and characterization, applications are built with different shapes. So when it comes to applications of nanotechnology, this is very important. Where we can use nanotechnology, what are the applications? There are a lot of applications can be seen, like automotive industry, chemical industry, engineering, and then medicine, construction, electronic industry. So, for example, if you say automotive industry, so there you can observe that the construction of bulk materials converted into tiny and handy material, like lightweight construction, painting, fillers, base coat, clear coat, catalyst, and tires, sensors. All these comes under automotive industry. Then chemical industry, fillers for paint system, coating system based on nano composites. Then impregnation of paper, switchable adhesives, magnetic fluids, and engineering applications where we can see protection for tools, and then anti-blocking coatings, coating on plastic parts, lubricant-free bearings. These are all applications under engineering field. Then medicinal field, so drug delivery systems, active agents, contrast medium, medical rapid tests, and antimicrobial agents, agents in cancer therapy. So where not everywhere we can use this nanomaterials in construction, also construction materials, thermal insulation, flame retardants, then surface functionalized building materials for wood, floor, stone. So nowadays the construction of buildings are also changing with the changing in technologies. So nanotechnology going into that field also, facade coatings and groove motors, all these under construction side. Similarly, electronic industry, that is data memory, as how we are observing that memory card size is getting reduced and reduced as the technology increases. So OLED, FED, and laser diodes, glass fibers, optical switches, all these applications uses tiny particles of relevant nanomaterials. So that is where possible in every corner of the technology to build with nanomaterials. Then these are some more applications of nanotechnology: textile, energy, cosmetics, food and drinks, household and sports, outdoor. For example, food and drinks, packaging materials are of disposable kind of things like environmental prone disposable material which are made possible with the nanomaterials. Storage life sensors. For example, if the medicinal food or the food which should not get spoiled easily, to put it in a better cover. So nanomaterial, it's made with nanomaterial of that kind of storage life increases. Then additives, then clarification of fruit juices, etc. All these made possible because of various nanomaterial and their properties. And similarly, when it comes to applications of sensors, so earlier we have seen applications of various categories, but especially in engineering side, if you see the applications like sensors, and these sensors are not only engineering, the construction are of engineering side, but the applications are of medical side. So biosensors, you would have heard about, or glucose sensor, or any kind of sensor. The sensors are generally made with nano kind of material inside, but the applications are related to electrical or medical. So improved monitoring and detection capabilities. Generally we may use to identify blood cells, or to identify glucose levels, to identify cancer cells. So these are various kinds of scenarios where you can use nanomaterials inside to make the sensors, and accordingly they will use for different applications. So each sensor may have different capabilities for detection and then control. So environmental protection, risk management, more efficient use of materials, and more data and waste. Similarly, then coming to the treatment, like cleaning up of waste streams of contaminants, particularly those substances that are highly toxic. During that time, intervention of human will get reduced, but only based on the type of material that used for making of such applications. So nanomaterials are used. Those substances that are highly toxic will be easily dissolved into environment using that kind of type of nanomaterials. So that is cost effective, specific and rapid solutions for treatment of contaminants. And then another applications like cleanup of contaminated sites, problems brought about prior uh, technologies and past practices. Now, similarly, we can have applications like atom by atom construction, less materials to deposit of. One is two aspects, which are generation of waste products and streams, design and pollution prevention at the source. Similarly, applications of green energy nanoproducts such as solar and fuel cells could lead to commercially viable alternative clean energy sources. Nowadays, battery management, battery making also different comparatively previous bulk battery systems. Bulk battery systems may produce more pollution to the environment, whereas nowadays the sleeky battery designs are coming up. Due to that, environmental pollution also getting reduced. So, biodegradable batteries, like nano products such as coming up with less pollution, solar fuel cells are coming up. And not only these batteries, various systems which are used in like embedded systems, lightweight composites, and small compact embedded systems. Coming to the industrial applications like um, yeah. Nano geochemistry, knowledge of formation of atmospheric aerosols, that movement of natural nanoparticles in air and soil can help inform the solutions to man-made problems. So here, this is another area where geochemistry, we can use nanomaterials for better identification of solutions for the man-made problems. So similarly, implications of toxicity, so essential to risk analysis for ecosystem and human health, and similarly implications of exposure, behaviorality, bio viability, bioaccumulation, implications of industrial ecology aspects, and all these are made possible because of the nano structure levels and applications of because of vast applications of nanomaterials. So these are various advantages we can observe.